Good afternoon, guys. So in this video, we're going to start looking at 3 by 3 systems of linear equations. So when we're talking about a 3 by 3 system, this means we have three equations and three variables. So just like with our 2 by 2 systems, we're going to want to find a solution that solves all three equations simultaneously. Now, the way that we're going to do this is we're going to take our 3 by 3 system and essentially use elimination to turn it into a 2 by 2 system and then solve it either using substitution or elimination like we did previously. So let's go ahead and take a look at this first example. And I'm going to label these as equations 1, 2, and 3. Okay, so what we're going to do is we're going to take these three equations and we're essentially going to separate it into two pairs. Okay, now how exactly you pair up your equations is sort of up to you, but you want to try and do it strategically so that it'll be easy to eliminate the same variable in both pairs. So I'm going to go ahead on this first one, and for my first pair, I'm going to put together equations 1 and 2. Okay, so that's equations 1 and 2. And then for my second pair, I'm going to put together equations 1 and 3. All right, so that's equations 1 and 3. All right, so what we're going to try and do now is within both of these two pairs, we want to try to eliminate the same variable from both pairs. Right now, it doesn't matter what variable you eliminate. You can choose X, Y, or Z, but it's important that you do the same variable both times. And the only thing that I would suggest is just try and pick a variable that looks easy to eliminate. So I would say maybe Y is going to be an easy one because on this first one, we don't have to do anything to it. We already have opposite coefficients for our y's. And on the second set over here, it'll be a pretty easy multiplication in order to try and eliminate that. So let's go ahead and deal with this first pair. I'm just going to go ahead and add these up. All right, so if we add these, we'll get 4x, the y's cancel, then we'll have plus 7z, and that'll be equal to 9. All right, so I'm going to go ahead and label that as equation A. All right, so now over here on my second pair, I want to eliminate that same variable y. So in order to do that, we're going to have to multiply this bottom equation through by a 2, which then if we rewrote this, top equation stays the same. And then our bottom equation would be 8x minus 4y plus 2z is equal to 12. All right, now we can add our equations together. Our y's cancel as we wanted them to, and we would get 10x plus 3z is equal to 8. And I'm going to call that equation B. Okay, so if we put these two new equations together then, so we have 4x plus 7z is equal to 9, and 10x plus 3z is equal to 8. That's our equations A and B together. We've now taken our 3 by 3 system and we've eliminated the y variable so that now we've turned it into a 2 by 2 system. Okay. So from here, we can just solve it like we were doing previously with our 2 by 2 systems, either using substitution or continue with elimination. So I'm going to go ahead and just continue with elimination. And I'm going to try to eliminate the x variable. Go ahead and just move this a and b over. Okay, so I'm going to try to eliminate the x variable because neither variable looks particularly easy to eliminate, so I'm just going to pick one. So easiest way to eliminate this would be multiply the top equation through by a 10. And then the bottom equation, remember we need to make sure that our two coefficients are opposite signs. So I'll do a -4. All right, so then go ahead and rewrite this. So we would have 40x plus 70y is equal to 90, and negative 40x minus 12z is equal to negative 32. All right, now we can add our equations together. The x's cancel as we wanted. All right, and then we're going to have 58z is equal to 58. So if we divide by 58 on both sides, we end up with z is equal to 1. All right, so that's our first variable. Now from here, we just need to back substitute in order to find our other two variables. So once you find your first variable, you're going to back substitute into either your equation A or your equation B. Okay, so we plug z equals 1 into either equation A or equation B. And it doesn't matter which one, you're going to get the same answer regardless. So I'll go ahead and just plug it back into equation A. So we have 4x plus 7 times 1 is equal to 9. If we solve this out, we get 4x equals 2, or x is equal to 1/2. All right, so then we have one more variable to solve for, and to find that, we go back to one of our original three equations, the 1, 2, or 3, and we plug in both the z equals 1 and the x equals 1/2 that we found, okay? So it doesn't matter whether you choose equations 1, 2, or 3, you're going to get the same answer no matter what. I'll go ahead and just use equation 1. So our equation 1 up here was 2x, we just found that x was 1/2, plus 4y plus z, which we found that z was 1, is equal to -4. All right, so that would be 1 plus 4y plus 1 is equal to -4, or 4y plus 2 is equal to -4. Subtract the 4 over, and we get, or subtract the 2 over, excuse me, so 4y is equal to -6. Divide through by a 4 on both sides, and we end up with y is equal to -6 over 4, which would reduce to -3 over 2. All right, so then just putting it all together, our final answer, just written as an ordered triplet, because there's 3 variables. We have our x, which is 1/2, our y, which is -3/2, and z, which is 1. Okay, so that is our solution to this problem. That's our answer.